Hey everybody, this is Mr. Ainsworth, and we're going to get into solving systems here by what's called double elimination. Okay, in our previous lesson in Algebra 1 here, we took a look at how to solve a system by elimination, or what's called single elimination here, where we eliminate only one variable, such as x in this case, because they had opposites here. Okay, you notice that negative x and x are opposites. We eliminated x and we solved for y, and then we use substitution to find the other value of the variable, in this case x, which was -8, and then we state the solution as an ordered pair. And we also talked about how we verify this solution by substituting into both equations here and show that it satisfies both. Okay, that was called a single elimination. We limited one of the variables, either x or y, and then we solved for the other variable by substituting into one of the original equations. Well, there's a way to avoid the substitution step here and do what's called double elimination. All right, so there's no substitution at all. Okay, so we're going to eliminate the x's and solve for y, and then we're going to eliminate the y's and solve for x. Okay, so let's state that. Okay, first thing, we'll do the first step here. We're going to eliminate the x's, okay, by creating opposites, all right, and solve for y. Okay, now to do that, you got to find and create opposites, and that's the goal. Okay, as I stated in the first lesson, let me go back to that real quick here. So right here, notice that I said you need to find or create opposites. Either they give them to you like they did right here, negative x and x are opposites, or you have to create them, and most of the time you have to create them. As in this case right here, 5x and 3x are definitely not opposites. But one of the things, one of the key aspects in this lesson here is to find, all right, and or, well, let me put or too, or create, okay, opposites. So you have to know what opposites are. Very important critical concept in the double elimination method. All right. Now the opposite of 5x is negative 5x, and clearly these are not opposites right now. So what you do is you multiply them by any value you want to create the opposites. Okay. And probably the easiest way to do that is to take the multiple of 3 and 5. All right, think multiples. Okay, now if you don't know what multiples are, you can research that. But a multiple of 3 and 5 can be found by multiplying them together, all right? 3 times 5 is 15. So you're going to think multiples. But you want to keep one positive and want to make one negative because opposites are an opposite in sign. Okay, same value but opposite in sign. So the opposite of, well, let me go back. 3 times 5 is 15. That's called the least common multiple of 3 and 5. And so you want to create one to be 15x and the other one to be the opposite of that, which is negative 15x. So let's suppose that I want this first equation. I want this term to become 15x. Okay, so I simply multiply the left side by 3, and that would triple all the values. All right, and I have to also multiply the right side by 3 as well. And that would create 15x plus 30y equals a negative 45. In fact, let's write that down. So 15x plus 30y equals negative 45. You got to multiply all three terms by 3. You have to distribute basically and multiply on the left twice and then multiply on the right once. Now the opposite of 15x is negative 15x. So how do you create that? Well, you take 3x and you multiply it by negative 5. That will achieve your goal because negative 5 times 3x gives you negative 15x. Remember that whatever you do to one side, you do to the other side. So you got to multiply all terms by the negative 5. And so what you get is negative 15x. And then negative 5 times 9y is negative 45y. So you can write it as a minus 45y. Or you can write it as a plus negative 45y. Either way, same thing. And then right here, that's a positive, okay, positive 45. So just keep track of your negative signs. And you're going to combine and add the equations working with like terms only. So you're going to add the columns basically. 15x and negative 15x combines to 0. We call that canceling out because these are opposites. Opposites always add to 0. Another key concept right here. Opposites always add to 0. That's a big bold statement right there. So opposites always add to 0, and that's why this concept works. Okay, 30y minus 45y is a negative number, and that's negative 15y. Negative 45 plus 45, well, that's 0. And hopefully you can just look at this and say, hey, negative 15 times what equals 0? Well, the only value that y could be to make it 0 when you multiply is 0. Okay, so y has to be 0. Negative 15 times 0 equals 0. So y equals 0. You can divide by negative 15 if you like, or you can just think about it. It's that simple. Okay, so notice that we eliminated x to find y, and now we're going to reverse that process. We're going to double eliminate here. So we're going to look here at the y values. Okay, so instead of doing what we did on the previous lesson, which was after finding a variable, backward substitute, notice the word substitute right here, and figure out the other variable. Okay, let's not do that. Let's learn how to use double elimination, or elimination twice. So we're going to eliminate the y's and solve for x. Okay, and so what we do is you find the least common multiple of 10 and 9, which is 90. 9 times 10 is 90. So what we want to do is create opposites. So I'm going to multiply this one by 9. Okay, what would that give me? So 9 times 5x is 45x. 9 times 10y is 90y. 9 times negative 15, well, that's negative 135. 90 and 45 is 135. All right, now the goal is to eliminate y's, so get your eyes right here. Okay, the opposite of 90y is negative 90y. So I got to create opposites, so I multiply this one by negative 10. Because negative 10 times 9 is negative 90, which is the opposite of 90y. Okay, and whatever you do to one side, you do to the other side, so multiply both sides. And what do we get? Well, we get negative 10 times 3x is negative 30x. Negative 10 times 9y is our goal there, negative 90y. I'm going to write it as plus negative 90y so you can see that they're opposites easier. Okay, or you can write it as minus 90y, same thing. And then negative 9 times negative 10, well, that's just 90. And then you add the equations, and you add like terms, add vertically. Okay, and remember our goal is to eliminate the y's. Watch what happens. So 45 minus 30 is 15, so I got 15x here. 45x's take away 30x's is 15x's. All right, these are the opposites. Okay, they combine to 0. They always add to 0. Just take a look. Key concept right there. All right, and negative 135 plus 9 is negative 45. So this is equal to negative 45. Just add vertically. All right, and add more negatives, so the answer is negative there. You can just think about it. It should be negative 3, or you can divide by 15, and you'll still get negative 3. And so my solution as an ordered pair, because all solutions to systems are ordered pairs, at least two variable systems, okay, linear system, well, two variable systems, okay, in this case is negative 3 comma 0. Okay, and you can verify that using Desmos. So verify using Desmos. That's one way to do it. You could you can use Desmos. You can use the TI-84, any other graphing calculator. You can use my program that I use all the time, which is a really cool program. I use this one to show in class right here. They don't have a keyboard, so it's a little bit tougher for me to show you. Well, I'll tell you what, I'll give you a shot, okay? Let me see if I can do this real quick. So 5x plus 10y. So let me pull this out here. So 5x, see if I can do this real quick. All right, plus 10y. All right, and that's going to be equal to, there we go, negative 15. So let me input negative 15. So equals, let me find my equal sign, negative 15. There we go. All right, now I need a new function here. So let's get another one here. And it's 3x plus 9y. So 3x, let me input this here, 3x plus 9y. This takes a while, but it's pretty cool. The end result's going to be really cool. Plus 9y. All right, equals negative 9. So, okay, there we go. Let's take a look at this here. So, let me see. Did I? I don't think I entered the system incorrectly. Let me check here. 5x plus 10y equals negative 15. 3x plus 9y equals negative 9. Whoa. Whoa, whoa. Let me pause the video and check something's wrong here. Okay, I'm back. So it turns out everything was fine. I don't know what I was worried about here. So let me go to the solution of the system right here. Notice that the coordinates are negative 3 comma 0. That's where the two lines meet at negative 3 comma 0, and that corresponds to what I have right here, negative 3 comma 0. Okay, so when you take this system and solve it by graphing, which is what I did here with the program, all right, which is a really cool program, or the Desmos or TI-84, any graphical software that you guys have, you can verify that it's correct by looking at the graph and see where the two lines meet. At this point is at negative 3 comma 0. All right, so always verify your solution. Negative 3 comma 0 in this case. All right, now that's how you use double elimination. So let's get good at it, okay? So if you want, you can pause the video and try it yourself and go through it on your own, and then press play and we can check our work here. You can do that, or you can, if you're not quite sure, well, you can listen to another example, okay? All right, I'm going to eliminate the x's first and solve for y, okay? Now 2 times 7 is 14, so I'm going to make one 14x, and the other one I'm going to make negative 14x. So I'm going to keep the top positive. So this is going to make 14x up top, multiply both sides by 7, and then I got to make the other one negative 14, so I got to multiply this one down here by negative 2, both sides. Use parentheses around the negative number so it looks like multiplication. All right, and let's go for it. So distributing through, we get 14x, all right, plus 7y is equal to 49. Down below, when you distribute through, you get negative 14x, there's your opposites, plus negative 2 times negative 3 is positive 6y here, and then equals 16. When you combine the equations, okay, you cancel out your opposites, and you're getting 13y is equal to 50 and 15, 65. All right, when you divide by 13, ooh, this turns out kind of nice, and that's 5, okay? 5 times 13 is 65. So we know y is 5. The question is, what is x? So let's create some opposites, okay? So take a look at the y's here, and I see y and negative 3y. So I just see that the opposite of negative 3y is 3y. So all I have to do on this one is just multiply the top by 3, and I'm set and ready to go. All right, so this one's a little bit easier. So here we get 6x here. 3 times 2x is 6x. 3 times y is 3y. Got to multiply everything, equals 21. And then just bring over the second equation because I didn't have to do anything with that. And when you combine terms, okay, notice that the opposites cancel, and you get 13x is equal to 13. 21 minus 8 is 13. 13 times 1 is 13, so I'm expecting 1. Or you can divide by 13, and you'll still get 1. So the solution on this one is 1, 5. Okay, notice there was no substitution needed. This is called double elimination because you do it twice, okay? Hence the word double, 2 times. All right, eliminate the x's, solve for y. Eliminate the y's, solve for x. Okay, that's all there is to it. All right, it just takes practice, okay? All right, so pause and play. Try another one here. Pause the video, and if you like, and then try it. And then press play when you're ready, and let's check your work. All right, time to check. Okay, so on this one here, the opposite of 7x is negative 7x. So the only thing you need to do here is multiply by negative 7 on the second equation. First one remains the same. 7x plus 15y equals 32. Next one, negative 7x when you distribute, and then positive 21y, because of the double negative there, equals negative 140. When you combine equations, you cancel out the opposites, and you get 15y and 21y, that's 36y, equals this. And so this is going to be a negative number, right? And in this case here, you're going to, you got 32 minus or plus a negative 140. So you know it's negative, so put a negative sign here. And then 140 minus 33, that should be 108. Okay, the question is 36 divisible into 108? Because you got to divide. Okay, and it looks like 3 times. I bet that's the case. 36 times, whoops, times 3. That's 18, carry the 1. It is 108. So y is equal to negative 3. You can even verify it. 108 divided by 36, all right, is 3. So answer is negative 3 because you got a negative sign there, right? Right. Okay, now the goal is to eliminate the y's. So let's go for it. The opposite of 15y is a negative 15y. And notice that the second term here, the bottom term in the second equation here, is already negative. So I don't have to make it negative. It already is. So all I have to do is multiply the second equation by 5, and it's pretty straightforward. So 7x plus 15y equals 32. Multiplying through, all right, you get 5x minus 15y is equal to 100. Canceling out the opposites here, all right. Always do that first. 5 and 7 is 12, so I get 12x is equal to 132. And you got to figure out, what do you multiply 12 by to get to 132? And it should be 11. Okay, you can check that. So you take 132 divided by 12. I sure hope it's 11. Okay, so the answer there is 11 comma negative 3. It is always, my friends, x comma y. Always. I'm going to highlight that. Okay, the solution to a system of 2 linear equations is always an intersection, which is an ordered pair, x comma y. All right, last one. Okay, to get some experience here, we're going to eliminate the x's, all right, and solve for y, and then we're going to eliminate the y's, and then solve for, that's going to be easy in this one, solve for x. Okay, first one, the opposite of 3x is negative 3x. So multiply the second equation by negative 3, both sides. Use parentheses around the negative numbers because you want to make it look like multiplication, not subtraction. So we get 3x minus 10y equals equal to negative 25. Distributing through twice or multiplying twice, you get negative 3x minus 3y. Excuse me. Or you can write it as plus negative 30y. Either one. I could do this right here like that. And it equals negative 15. All right. Cancel out your opposites like I always say here. And you get negative 10y plus a negative 30y is a negative 40y. So keep track of those negatives. And over here, negative 25 and negative 15 is also negative 40. So y has to be 1 because negative 40 times 1 is negative 40. So that's pretty straightforward there. Y is 1. The question is, what's x? So right here, this one's simple. They're already opposites. So just combine. So right here, I get 4x, right? 3x plus x is 4x. These cancel out. Negative 25 and 5 is a negative 20. All right. And just look at here, you guys. 4 times negative 5 is negative 20. So x is negative 5. So my solution is negative 5 comma 1. Again, it's always x comma y. Okay? And that's all there is to it. Sometimes double elimination works really, really smoothly. Like this one worked out swell. Okay, swell. That's a funny word. That's back in the 50s when they said that. I meant to say well. So you can double eliminate, or all right, you can single eliminate. It doesn't really matter. You can do it the way we did in the previous lesson on 6.3, part A here, and do single elimination and substitution. Or you can use double elimination, as we did here 4 times in a row, and solve for the unknown. It's totally up to you. It's up to you. You get to choose. Sometimes this is harder than single elimination, so you got to think about it before you do it. All right? You do what's best. All right? So this is solving systems by double elimination, or just simply the elimination method, sometimes called the linear combination method or the addition method. I like the elimination method just because it kind of makes sense, because we knew what eliminate means, So I'll see you in my next lesson here in systems here, and you study hard, work hard, make yourself proud. I'll see you in the next lesson.